Good afternoon, everyone. Welcome to this discussion on data and digitalization. When we think about data and digitalization, most people usually think about demand response. This, however, is not what we're going to speak about today so much. Demand response is, companies are already doing it. Main challenge in demand response is interoperability a lot. And intellectually, that's very close to being solved. We are now working with the grid operators to really bring it into life. We are also not going to speak about grid management technologies, so dynamic line rating, better reading of the substations, all super important topics, but that's more for the grid operators to work on this. What we are going to talk about today is the digitalization and the better usage of data in PV companies themselves. When I started this work, I was quite surprised. What I heard is that we live in the stone age of digitalization. When during our last strategy day, the discrepancies between the companies that are super digitalized and those that are just starting were super large. We had the companies that had all their data taxonomized, they had their database, they could go not only to asset level, but to the different components of their assets and really analyze how these assets perform. And then there were companies that just started to map which kind of assets do they have in one database. So really the distances are quite huge. And it is quite surprising because what we hear is that 20 to 30% of the LCOE, of the revenues of the PV installation, is from OPEX, from operational costs. And actually the biggest levers to increase your returns is from digitalizing your asset and getting a better grip on your asset management. So in the following 1 hour, what we're going to do is we're going to have 2 presentations from Giuseppe and David to show you what is the future of digitalization in PV. We are going to speak about the challenges, what is the potential and why are we actually doing this. And last, we're going to speak about what specifically PV companies can do to get their feet and go faster on the digitalization journey. Now, before we start the discussion, I'd like to ask you to scan the Slido. We're going to do a Slido question. And the question will be, raising the topic of data and digitalization in your company raises A, enthusiasm and support, B, confusion, C, anger, or D, please file a paper request. So I'll give you 30 seconds to respond.
D will win.
Okay. That's option E. But until then, I'm going to welcome the first speaker. It's Giuseppe Ferraro. He's the Director of Innovation and Green Power Monitor for DNV, responsible for developing the cutting-edge digital solutions for the renewable energy asset management. You have a background in technology and data-driven solution management. Of course, you optimize PV and wind operations for the countless assets that you have in your portfolio. Great that you're joining us. Giuseppe, the presentation is yours.
Thank you. Thanks.
And we can see, wow, 70% have enthusiasm and support. I saw there's some 20% confusion. We're working on it, but generally we are looking in the right direction.
Okay, good afternoon, everyone. I've been given the interesting challenge to keep you awake after lunch, so I'll try and keep up to the promise. My name is Giuseppe Ferraro. I'm the Director of Innovation for Green Power Monitor, part of the DNV group. Today I'm going to be talking about data to enable efficiency and how we use AI into operation. The company I work for runs something like 80 gigawatts, more than 80 gigawatts of renewables combined between solar, wind, and storage. And we offer 2 main solutions, SCADA and systems to monitor and analyze data and predict what's going to happen with the assets operating in the field. So let's start. I'll try and set the scene. So what's the prerequisite to data-driven strategies? So if we want to use data, of course, we need, in general, a lot of data. But data, we need to understand whether data is usable. And our experience in Green Power Monitor is that usually data is not as usable as it should be. So what we try and do is to ensure that we've got what I call data excellence, so that we can use data at scale and deploy solutions very quickly. Are we there? Well, we are getting there. The industry is not there, and I'll show you a bit of the work that we've been doing to ensure that we can get there very quickly. And what we have done is we've also used AI to ensure that data is usable at scale and at speed. A bit of my personal journey. So the baby in the picture is not me because I haven't got blue eyes, unfortunately, but it's me when I started in Green Power Monitor. We had something like 60 gigawatt of renewable assets and a lot of data. And I thought, okay, data equals insights, so we're rich. We've got plenty of things that we can do, and we are going to be using this data very quickly to ensure that we can serve our customers even better. Unfortunately, that was not the case. Data doesn't mean insights. It's usable data, it means insights. If you've got a lot of data and you cannot use the data, most of the times you're liable to keep the data safe, so it's more of a liability than a richness or something that you can trade or you can use. So to overcome the challenge, what we have done is we have created a data taxonomy, and you might ask yourself, what's a data taxonomy? Probably most of you already know what data taxonomy is. And I like analogies. So data taxonomy means that you're trying to give an orderly way of looking at data in terms of how they're called and that they respond to the same nomenclature and also the order in which they are stored and saved in different databases. Just to give you an idea of the challenge, just imagine that you've got something like 7,000 plus sites and you're trying to deploy a machine learning or AI-based algorithm. And for each site, considering how many devices you've got on the site, you have to constantly rename the inputs to your algorithm to deploy at scale. That's not going to happen. That doesn't happen in reality. So the analogy of the rug is when you don't have taxonomized data, it's like if you are colorblind and you're trying to make a rug. So you might end up with a rug that is more or less functional, but the pattern that you probably were trying to achieve is never going to be there. And in the data case, it's probably even worse than the analogy. So for that reason, we have developed the PV taxonomy, but we have gone a step further. What we have done is we have developed an algorithm that applies taxonomy in an almost automatic way. So we get in unstandardized data from our customers. So we put that through renewable taxonomizer, which is the name that we have given to the algorithm. And with minimal input and human feedback, we get taxonomized data out of the tool. So what we have managed to achieve is a very powerful duo, which is the taxonomy plus a tool that deploys taxonomy at scale. By doing so, what we have managed to achieve is that when we are migrating sites coming from customers that are not on our platform, or even when we are migrating data from different tools within the same platform, we are 9 times faster than we used to be. The onboarding of a new sites has become 4 times faster, and we have increased the number of data, the amount of data that we can use by 3 times. So as you can tell, it's quite an interesting improvement. Now I would like to look at AI, how AI has improved the way we enable efficiency for our customers. Let's assume that all of our data has been taxonomized now, and I like to start with the basic principles before describing the fancy features that we can deploy to our customers, like soiling trackers or degradation of solar panels. The key for us to identify efficiency and enable efficiency is in the identification of expected energy. I've got a slide here that explains what expected energy is for the ones that are not familiar with it. So during the pre-construction phase of solar assets, whoever is going to deploy or develop the site runs a pre-construction calculation, assumes a certain resource, so solar and temperature usually, and then they run what is commonly known as the 8760. So try and predict what energy is going to be produced by the plant for every hour of the year for the next 10 or 20 years. And that's the theory, that's the discrete analogy of what the model will predict in terms of the production of the plant. Then the plant is going to be built. So on the graph, you'll see that I've put on the x-axis the development stage and on the y-axis the energy. And what happens is that there is someone who's going to be looking at the data in the operational phase. So you've got the resource that, of course, changes constantly. So it's not on an hourly basis, but it's something that changes constantly in an analog way. And what they're going to be looking for is the measured energy. So how much energy the asset produces. And of course, they're going to be comparing that to the expected energy. So the question that everyone running the asset to ensure that the numbers make sense and that the revenue that they were expecting is in line with the business model is the plant operating okay, is producing as much energy as it should be producing considering the changing conditions of the plant. If that's not happening, what essentially we are looking for is the losses. So that's where we focus on in terms of identifying that there is a loss, there is an inefficiency. How do we go about creating or assessing or forecasting the expected energy considering all the parameters involved? The plant that changes, the resource that changes, the glass that falls down, and essentially all these parameters changing all at the same time. What we usually do is we've developed two digital twins. One is machine learning based, and then the other one is a physics-based model.
Giuseppe, we have to keep a bit of an eye on the time.
Okay. So yeah, we've got a physics-based model and the machine learning-based model that is learning from the good behaviors of the plant and gives us an idea of what the expected energy should be. We have created two models because you can also learn from a badly installed plant. I should go to the conclusions. I had some validation results, but in terms of the conclusions, my suggestion is usually starts from the basic, taxonomize your data. AI can be used to taxonomize the data, and we have seen that it works. It's a fantastic tool, but it's not the only tool that can be used in PV and in renewables. And I also think that the future is bright with the right data and the right tools, so we can do a lot of very interesting things.
Thank you very much, Giuseppe. We have a second presentation, David. David Moser is the Managing Director of Becquerel Institute Italia, where he focuses on solar energy market analysis, digitalization and innovation in PV performance assessment. He holds a PhD in renewable energy systems and has extensive experience in research, data-driven decision-making, and AI applications in PV. Welcome, David.
Thank you very much. And I think this presentation comes really nicely after the presentation from Giuseppe. So everything that Giuseppe explained is on the left-hand side, predictive AI. But there is a new way of AI that is called generative AI. And I think the presentation could really finish here, to be honest, because the two key novelties that are introduced by the generative AI is the first one is that it mimics creativity. So it basically acts the same way that we would act, and this is a revolution. And second, it democratizes the access to the sources. And I will try maybe to explain better the second part, the democratization of the access to data. So before we saw everything related to the insights engine, can be nicely done, you can apply all the possible algorithms to that, but then you have the user. And not everyone is an expert, not for everyone it's easy to understand the data that you have on complicated dashboards. So with generative AI, you can introduce a new concept, that is the agentic user interface, is someone, an artificial intelligence, an AI agent, I will explain later what it means, that can do this job for you, for the end users, can translate complex and complicated information into something that all of us can understand by adapting to the language. So the new wave of generative AI introduces the idea of AI agents. An AI agent is essentially a program that is capable of performing tasks on behalf of the user. And this is, again, is something extremely new that will revolutionize the sector, all the sectors, but the focus of today, of course, is the difference, is the solar sector. It can come with different user interfaces. You can have it on your phone. You're all familiar with ChatGPT and so on. So imagine having a specialized AI agent, specialized in monitoring, in looking at monitor data, in looking at tickets from the field, in the design of a PV plant. So you can start thinking about, in the future, which of these tasks could be potentially transformed into automatic pipelines. So these AI agents, they can watch over assets, and they can go beyond data retrieval. So it's not just about looking into PDF files or DWG, CAD files or contracts or so on. They can act for you. So Giuseppe in his presentation before mentioned that the users is in the control room, and then there will be an user that will send someone, a team, to the field. Imagine if all of these can be partially substituted by AI agents with human in the loop that can improve let's say, the feedback loop. And it's really about building a dynamic relationship with your PV system. When I say the next sentence, I know that people laugh, but let's see if we are still laughing in a few years. So you will be talking to your PV system. And this, I believe, is really the revolution of the new wave of AI. So this is a paper that was published in March 2025, 2 weeks ago. It's not about solar, but it's about time horizon. So what is time horizon? It's the duration of a task that an AI model can complete with a specific success rate. And they already demonstrated that there are tasks up to 8 hours that can be entirely done by AI agents with a success rate of 80%, which is probably sometimes better than some workers in the field. And jokes aside, what it also means that you can do the same task with at least cutting the cost by 90%. And if you extrapolate the curve, the people believe, like experts in foundation models, in creation of foundation models, they believe that by 2028, 2030, AI, they could, let's say, run fully automated pipelines for tasks, complex tasks, up to 1 month. So I don't know how many tasks in solar they can last up to 1 month, but you can imagine already how many of the tasks could be taken over by AI agents. Now, we are working on the impact of AI in the PV sector. Big disclaimer, it's an ongoing analysis, so I'm just going to show you some examples for operation and maintenance. So we believe that when you start adding robotics to the use of AI, predictive AI, and generative AI, for example, in the OEM phase, you could probably automatize 80–90% of the tasks. There is also the economic impact and the workforce impact. I think there will be time during the panel discussion to go a little bit deeper into that. Imagine that in this analysis, we are doing this analysis along the whole value chain, so we really hope we will be able to share some data soon, possibly during Intersolar in May. I would like, for the workforce impact, I would like to reverse the message into a positive message that AI plus robotics can enable unprecedented scalability of solar deployment. So it doesn't mean that we need to, let's say, fire people, but it means that OEM operator can deal with a larger portfolio, asset managers can have a larger portfolio, PV plant developers, CPC, they can build more plants in a faster time. So let's reverse the message into a positive message, also to mitigate the skill shortage that currently limits or will limit or might limit the industry expansion in the future. So to finalize, just to show you that it is not all fantasy, those are AI agents that were developed by a former colleague of mine. They are talking to each other in an inspection room. So they see a problem with a PV module. So they send a robot to take a picture. The picture doesn't show anything bad. So they say, why don't you take a picture from behind the modules? The robot goes behind the module, take a picture, nothing wrong. And then they continue, they take an infrared image, they see a hotspot, and only then they communicate to an operator. So everything that is happening there, humans were not aware about that. It happened entirely in an automatic way. And I conclude with leaving some questions for the discussion. Thank you very much.
Indeed, that sparked some questions. So thanks a lot, David. So now introducing the other panelists. Or before that, I'd like to start the Slido with the question. What are the challenges? So you have now seen the potential of introducing data and AI in your companies. What challenges do you observe in your companies in actually implementing these solutions in your companies? So now, using the time, so introducing the other panelists. So first, we have Susanna Wood, who is Vice President of Public Affairs and Sustainability at the Statkraft, the utility, also board member at Solar Power Europe. So you lead the engagement of Statkraft in energy policy, sustainability strategies, and regulatory affairs. You have background in energy policy and stakeholder relations, and of course, you lead Statkraft's strategy in these fields. So welcome, Susanna.
Thank you.
Applause, please. And then we have Stavros Stamatukos. You are the policy officer at DG Enea. You lead the digitalization and AI portfolio in DG Enea. You have background in energy policy and technology governance, and you play, of course, a key role in the EU's data and AI strategy in the energy sector. So welcome, Stavros. Now, going into the first question. So, Stavros, starting with you. You lead the data and digitalization team in DG Enea. From your perspective, what have you seen as the key barriers for data, and how is the Commission planning on addressing them? After that, we're going to look at the Slido.
Right. So let me picture a theoretical scenario that you have an aggregator or a service provider, let's say based in Belgium, that they want to manage a portfolio of, let's say, some thousands of electric vehicles based in Finland, Sweden, Netherlands, and whatnot. A portfolio of, let's say, rooftop panels, also based in 3 different countries, and a portfolio of heat pumps, again, in a number of different countries. So they need a constant communication with all these assets to aggregate in potential virtual power plants, the flexibility potential of these assets, and then bid this flexibility potential in local flexibility markets. So communicating all the way down to the asset and then all the way up to the grid operators and the energy markets. It's pretty complex, right? And I can tell you that it's not happening. But that's the objective, what we are trying to achieve at the European Commission. It is partially happening in silos, so under concrete, let's say, commercial silos, where the provider of the equipment is also an aggregator and is also the utility that bids the flexibility to the market. But the objective of the European Commission is to open up this market to any participant to enter the market and bid all these assets to any local flexibility market in Europe. In 2022, the Commission has adopted an action plan for digitalizing the energy system, and that was the #1 priority, to create a data sharing framework that any actor can get access, secure, and in a secure and coordinated fashion to this data, or let's say, to those data necessary to provide these innovative energy services. We are using an approach which is called data spaces. Maybe I can explain later on, but the main instrument that we are currently using is an expert group. So we gathered all relevant players, all the way from the grid operators, market participants, equipment manufacturers. Solar Power Europe is a member of this expert group, a very active member, and the member states. very relevant. And we're discussing around the table, starting all the way up of defining all these use cases, all this theoretical scenario that I explained before, mapping all the different actors that they need to participate in this data exchange. And then the engineers and the technicians, they go all the way down, analyzing which are the data that need to be exchanged, let's say the necessary data, which are the protocols, the interoperability requirements. So we're talking about data ontologies and data points. And in the end, we are trying to create this data sharing environment that make all these players and all these devices speak to each other. And again, and let me highlight, it's not just for sharing data, it's for offering innovative energy services. So this is, we're working with two use cases. One is demand side flexibility, and the other use case that it's even more complex is the smart and bidirectional charging of electric vehicles. And this is more complex because behind the meter, we have the ecosystem of mobility actors. So we have all the car manufacturers, battery manufacturers, and the charging point operators. So we are bringing players from two different sectors, I would say, industries together. And we're trying to define all these data exchange requirements so the data can be shared and exchanged securely to offer innovative energy services. In parallel to that, and I will close, we're trying, this is the bottom-up approach, but and what we call soft legislation, but we obviously from the European Commission, we are pushing from the legislative front as well. Probably you're aware of the Data Act that defines the general principle that the data of every connected device, any device that is connected to the internet, the rightful owner is the owner of the device. So if for my phone, I'm the owner of my data. For my car, I'm the owner of my data, even if they are stored in the cloud of my provider, my manufacturer. I'm the owner of the data, and I can give access to this data to whomever I want, if it's my aggregator of my service provider. There are many more sectorial legislations in the energy sector, the Renewable Energy Directive, the Energy Performance of Buildings Directive, and many more, that they are trying to put this obligation also in national legislation. But the effort is done mostly bottom-up from the players themselves, that they try to agree on these common principles, how to exchange data to allow these innovative services.
Thanks, Stavros. And indeed, the efforts on interoperability are super important, and PV companies really appreciate them. Lea, could you show the slide with the the question was, which challenges do you see when digitalizing? We see security and optimization. We're going to speak a lot about optimization. Security, we already touched upon it later. Security, we already spoke about it before. Gathering data, standardization, taxonomy, I see. De-risking, information security. So taxonomy appears quite a lot. Okay, I think the discussion is on the right path. So let's move to the practical perspective. Susanna, you work with Statkraft, and we know you've been engaging with Solar Power Europe a lot on several projects in this field. Can you walk us through some of the digitalization projects that you have run at Statkraft?
Hi, everybody. So I need to, we've been involved in a number of projects that have been supported by the EU. So there was the Solar Bankability Project, then Trust PV, and now that's been replaced by Supernova. But just to go back in time a little bit, so before we were part of Statkraft, we were a solar-only company called Solar Century. We'd started building solar projects where we were on the hook for the contractual requirements of those solar projects. And the systems were beautifully built, beautifully designed, but the monitoring was a nightmare. And I'm talking about 10 years ago, right now. So everything, and it was honestly, it was like our constant headache was the monitoring of these systems. And I'm sure that everything has moved on a lot since then. It was a decade ago, which as we know is a lifetime in solar. But it was something that we really had to address because we weren't able to fulfill contractual requirements based on what was being provided to us. We didn't have visibility of how this was being done. So we took a decision to build our own team. So we now have a team of 7 data scientists who are only looking at solar. There are other data scientists around the business looking at hydropower, wind, etc. These guys are completely focused on solar. They're incredibly dedicated, very curious team, very talented at what they do. But the downside of going in-house is you perhaps lose the perspective of what's going on outside. And I think that's one of the major value for us participating in these EU projects, is that we've been able to share and we've been able to borrow. We've been able to collaborate with other companies, companies that are in similar situations to ourselves, or companies that are providing drones, or trying out robotics. We're getting exposed to all of that at a very early stage. But the team are very experienced and have been working on. They've been using machine learning and AI basically for years now, and I would liken it to, well, originally it was a little bit like I remember a talent contest where a guy could look at a piece of vinyl and he could tell you what the music was. And it was a bit like that, and then it sort of progressed to something a bit more like The Matrix, where they could look at all this streaming green numbers and they could say, oh, that needs cleaning. And we're now really beginning to see it come through in terms of something that is more like a digital twin, where it is more 3D, where you can actually sort of drill in. And I'm very interested in your picture that you drew for us of actually the robots going and finding all the problems for us. We're definitely not at that stage, but we're certainly on that trajectory. We're very much on the kind of progressive side of things here. So we've been all that time working with the EU, working in this amazing space. We've been improving our algorithms, trying out new technologies such as drones doing thermography for us, improving our decision support model, which we think is quite good, as well as, I think, I think this is the case, that we have actually been building trust in the sector as a whole for what solar can do and what it can deliver and what a reliable technology it is.
Thanks a lot, Susanna. It's great to see that you're already so much advanced. What you say is monitoring has been the biggest challenge. I remember this from other conversations. Giuseppe, when you try to monitor your assets, when you try to get a hold of your assets, what are the challenges that you see when a company calls you at DNV and says, "Can you please take over our portfolio?" What are the challenges when you start to onboard to take a better look?
Yeah, many challenges. Well, some of them are related to lack of information, lack of standardization. You have to imagine that the team that runs onboarding is a team of people that is constantly on the phone to try and gather the right information to ensure that the data that is coming in makes sense for us to give useful insights to our customers. And that's not always the case. I feel like during the construction phase, data is considered like, as a given, not something that can have a massive effect later in the life of the assets. And we are paying the price for that. Unfortunately, the poor onboarding engineers are paying the price for that. To give you an idea of what we are aiming for now, when we deploy a new feature, the target that we are given by the onboarding team is that it needs to take maximum 20 minutes per site, per feature. So that's the order of magnitude that we are aiming for, because otherwise it's impossible. And that's not just to give a signal, but it's those machine learning and AI-based algorithms I was talking about. Mm-hmm. And that's one of our targets. We're not always meeting them, but we aim to reduce the onboarding time during the development of the algorithms.
Okay, so I understand that really getting the information and classifying the information is really the key step that is hurting, where the shoe is hurting at the moment, and where we are working on. So I'm going to skip the third Slido because I think we already know the taxonomy is and the data optimization is what we really want to speak about. But sticking to you, Giuseppe, do you have insights on the revenue, the additional revenue that you can generate once you have a beautifully taxonomized set? You created maybe a digital twin from it. What is the financial impact that this has on your company?
Yeah, I don't have absolute numbers. What I can tell you is that the way we work is based on something we call value to cost ratio. So what we try and do is prioritize the different developments based on the value that we add to our customers. And what we do is to try and understand the impact of specific features on the losses or on the revenue or on the energy generated by assets. If you look at typical assets based in different regions, per average size of PV plant, you can generate between 10 million and $4 million US dollars per year. So if you think about the effect of something that improves the revenue or reduces the losses by 1%, it's clearly a lot of benefits that go between $40,000 and $100K per year. What we do is we try and tend to focus on the bigger offenders. Usually, unfortunately, inverters are the main ones, and then we go with the priority list that goes from the bigger offenders to the lower offenders.
Mm-hmm. David, Susanna, is that something you confirm these numbers, the impact? Maybe you just want to nod if that's.
On the numbers, yeah, it sounds about right.
Okay, but great to hear that. Then moving to you, Stavros, we are still seeing the AI boom, the AI bubble. We still don't really know where it's going to end. If all our stocks are going to down in a few months. What are the Commission's priorities when it comes to AI and data? Are you planning on making us catch up with the US, or what is the objective here?
Well, yeah, I can already tell you that in the next days you will hear a lot about AI coming from the European Commission. So on the 9th of April, there is a new action plan, which is called AI Continent. And the objective is I would say twofold. One is to increase by 3 times the compute capacity of the European Union. Meaning data centers, high-performance computing, and probably you have heard the notion of the AI factories. So AI factories can be seen as ecosystems of developers of AI solutions, deployers, and all the players in between that they offer services that can be set around high-performance computing capacity. So there are 13 AI factories that they have been announced already in different European countries. So the objective is to build around those AI factories these ecosystems. So for the energy sector, I can already tell you, and it's a part of the Affordable Energy Action Plan that we published last month, that the Commission will develop a strategic roadmap for digitalization and AI energy. And this strategic roadmap will address the specific needs of the energy sector. So in the energy sector, what we need, first of all, is fast deployment of all these technologies in operational environment. We have excellent results in research and innovation domain. But what we have identified is that it takes time to bring these innovations to the market. And we're trying to address the barriers, be it funding, be it access to compute capacity, access to private or public funding. But the energy sector, we believe that it's a very well advanced sector. It has embraced digitalization very early in the old days of oil and gas, but then now with the renewables. We have excellent startups around about grid management services. And this action plan will bring the enablers to bring all those products to operational environment. On the other hand, the energy sector is in the unique position to bear the challenges of artificial intelligence, and this is the energy consumption. For now, energy consumption in data centers is not a big problem in Europe as a whole. We're about 2% of final electricity demand consumed in data centers. The problem is that this consumption is concentrated in 5 hubs in Europe, around Frankfurt, London, Amsterdam, Paris, and Dublin. And this is because data centers are located there for different reasons, because their clients are there, the telecom cables are there, and this is a problem for the grids in these regions. So if we continue this compute infrastructure development at this rate and without improving our planning, we will be in trouble for the grids, mainly. Mm-hmm. The grids are already strained, connection requests are extremely long, and so all in all, to conclude, we are all positive for all these deployments of data centers, but it needs to be in a planned way and in a sustainable way, and try to integrate it in the electricity grids as sustainable as possible. And I'm talking here about co-location with renewable assets, I'm talking about flexibility coming from data centers to the grid. So all these are solutions that we are exploring for now, and we see how we can bring them forward in our strategy. So yeah, to conclude, AI is here. We have to live with it. We have to take all the benefits. I mean, they say that AI will increase by 4 or 5 or 10% electricity consumption, but the benefits that we will get will certainly outweigh these challenges, and we have to embrace the benefit before we are confronted with the challenges, and this is what we're trying.
Well, great that you have such a balanced view, taking into account the opportunities and also covering the challenges that go along with it. So let's move on to the concrete use cases for data and digitalization. Let's talk a little bit about the digital twin, Giuseppe. So once you've onboarded the asset, you already said in your presentation you create a representation, a digital twin of the asset on your computer. What is it? How does this data get used in practice? In real life of an asset manager?
Yeah, well, first of all, I think that there are multiple levels of digital twins, and you can go from the descriptive, diagnostic, and predictive, and then you can elevate to other levels. If we look at the first 3 levels, we usually acquire data coming from the assets, so data that is generated from the assets, and we put them into our tools to enable our users to look at KPIs and to check the behavior of the assets. Another thing that we usually do is look at diagnostics, so signals coming directly from the assets to really give us an idea of what potential faults are occurring on the assets while the asset is operating, to be very focused on where the technicians need to go and what they need to look for and what spare parts they need to carry with them. And that's not just on the solar side, it's also on the wind side, where interventions are even more onerous because you're talking about blades and big components. And then there is predictive, so looking again at data generated by the assets to try and ensure that we understand what's going to happen next. We are developing twins, for instance, for fault detection or prediction of faults on inverters based on temperature and other parameters. So those are the main things that we are doing with data and with digital twins. And of course, the machine learning digital twins and the physics-based to run the expected energy calculations. That's just the beginning of the investigation. Because once you have identified that there is a gap between what you're expecting and what you're producing, then you need to really understand where the loss is happening. So you want to attribute the loss at a certain level and then distribute the losses through the full chain, going from the meter point down to the panel level.
Okay, so interesting. So you start with just giving the asset operator visibility on what the asset is doing. Then you see how do you improve or how you do fix problems, and then which problems will you have to fix in the future.
Yes.
So it's very concrete. Now moving to you, David. When we look at Gen AI, how can asset operators use Gen AI in their operations?
Well, I will start by integrating what Giuseppe was saying. So it was interesting because my experience was in the project that was cited before by Susanna, so Trust PV and so on. A lot of discussion with asset operators on the need of digitalizing, and everyone agrees. But then when you start discussing about digital twins and so on, they look at you and they say, what is it useful for? And to be honest, from a scientific point of view, I was able to explain it. From a use case, everyday point of view, it was a difficult task to convince people that having a digital twin was important. To your question, Gen AI helps us finally in understanding the need of digitalizing, because once you have a digitalized asset, you can enable all the use cases. So you can take tasks that are normally done by people, and you can partially or entirely use generative AI to take over. So the example that I showed before is only possible if I know where a component is geolocated within a certain PV plant. Otherwise, the robot doesn't know where to go. So that's the reason why it's important. Other examples are the ability of Gen AI to adapt to a language that can be understood by everyone. And this is, I think, is something that is extremely important. Maybe we undervalue it, but it represents in the residential and C&I sector a revolution, because then you have people with their PV system on the roof. They could actually interrogate the PV system in a way that is understandable for them. And Gen AI will adapt automatically. You don't need to do anything. It will adapt, and you will have a dialogue and say, I still don't understand, until finally it will be explained in a way that is easy, like a traffic light system or a thumbs up or down or whatever. I played with my kids, I tested them, and then they understood, so I think it works. They are particularly bright, but I'm joking. C&I is the same. You have a company, you nominate an energy manager. Not necessarily the energy manager is an expert in energy. It could be the facility manager. The facility manager probably doesn't understand necessarily how a PV system works. If you can bypass complicated dashboards and retrieve data and explain data to these people, we really expand the use cases by a lot. And then we go to utility scale, where potentially another interesting use case is you are a CEO, CFO, CEO of your portfolio. You have to wait until the end of the month until there is a person who worked probably a week to prepare slides for you. That can be completely bypassed, because you could potentially just through an interface that you know very well send a vocal message and say, how is my portfolio going? And the agent will reply immediately. Mm-hmm. So just to give a few examples, but there are many, many more.
Very, very tangible. I'm also thinking about the session on buildings yesterday, where it's so much about communicating with your customers. So that might also be another application.
Absolutely, yeah.
So to close, before we go into questions, Susanna, we've already heard you are fully embracing the journey. What are the next steps for Statkraft?
Yeah, so the next steps, is to expand what we're monitoring. So obviously, there's batteries are an obvious one, where we want to onboard batteries into the same process that we have for solar, which is much more established. And actually, one thing that hasn't really come out of the Slido for sure is that one of the real difficulties here is getting the contractual KPIs into the model, because they, one solar system and another solar system tend to be more similar than the contract for that solar system and the contract for that solar system. And when you've got PPAs in place, for people who want a solar system that is available 24/7, for example. So the contractual requirements of getting those into the system and making that easier, and we actually want to use AI to start kind of scraping the contracts, but also producing the contracts and aiming to get more consistency there. But we want to get batteries on board, and we want to do more on some of the other equipment. So, for example, the transformers. We're getting very little data from the transformers at the moment, but we can see that when there's some kind of temperature event, there's also we've observed physically something to do with oil in the transformer. We don't know the connection yet, but to be able to kind of just see some connections, have the curiosity, have the time and the place to actually go and investigate that and learn what it means and how to just to start to model it and understand it better. We found we've actually found something in a particular inverter that has not been documented before. When temperatures go up, there's something that happens in this particular inverter that no one's written any literature on it about before. So there's always something to go out and learn about, and so carrying on with the digital twin, making that better and better, carrying on with the deployment of AI, and increasing the amount of equipment that we're monitoring at the same time.
Sounds like a good vision to go for. Thanks a lot. Are there questions from the audience to the panelists? I think you can just speak up.
Also put it in there, and there were a couple of. Thanks.
Hi. So, hello, I'm Peter Weich from Belectric. We're an EPC. So we are enthusiastic about AI, but we learned also the last days there is a lot of invest and research on the front end when you do planning of projects, and at the end when it's constructed and asset managed and maintained. Is there any brave ideas, anything in the pot, because it still needs to be built and constructed, to use robotics and artificial intelligence during that phase of the project?
Sorry, I didn't fully understand the question. So you're asking about automizing
Automized intelligent systems that self-construct or erect the power stations.
I can try to reply. In the analysis that we're doing for the whole value chain, of course, EPC is the one where it will be more visionary to go in that direction. However, there are already companies looking into that, how to integrate robotic solution to move modules and speed up installation. But I think it will be the field that where the jobs are more secured from that perspective, more difficult to automatize. Just to give you a value, again, take it with a little bit of grain of salt because it's not been validated, but I think 25-30% of the task in the EPC can be automatized. The rest is still it's a job for people.
The engineering is the most obvious one.
Yeah.
Please.
Thank you. My name is Thomas Sauer with Exergy. I'm totally enthusiastic about AI, and David knows this, at least. I have nevertheless one question. How do we make sure that we and future generations don't lose our brains? The reason I'm asking, well, everybody's laughing, so I don't have to go further. Just take it as is.
It's too late. Too late for me, anyway.
It's a very good question. I think it depends how we measure intelligence. For example, if intelligence is measured on the ability to write your own Python code from scratch, I think that will disappear. If the intelligence is measured on how you do the right prompt to AI to get it done properly, that still requires human intelligence. So we really need to revise and rethink how we measured and we define intelligence, human intelligence, our role in the process, I would say.
Yeah, but I'm more driving towards how do we make sure that what AI suggests as a solution makes sense?
Because we keep human in the loop as an important part. It will be a part that will avoid hallucinations of the models, increase the trust of the results of the models, and I think it will be needed for the foreseeable future.
Yeah. I mean, my experience, I like analogies, is I consider it a tool. I'm a structural engineer, and in the past, we used to run structural analysis using hand calculations, and then we moved on to finite element analysis. And I think that artificial intelligence, we should consider it a tool, is revolutionizing the way we do things. It got to a different level, but it's still a tool.
Exactly. And that's what we need to be aware of, that it's
Yep.
staying to be a tool.
Yeah.
And if
Let's
I can
see about it.
If I can
Have a
add
different
very
opinion.
shortly, for critical operations, human oversight is a legal obligation for any AI system still. So I'm talking from the policy perspective, but there is the provision there, and for a reason.
Yeah, I'm a bit a layman over here. I'm a developer. So, but I have one question that makes me wonder is we were mentioning before that it was difficult to basically get everything digitalized and smart and communicate with each other. But is that also not because there is sometimes simply a lack of demand? So, because if there is demand, there is always some kind of creative software company or an entrepreneur who will pick up the challenge. And sometimes I think but maybe I'm wrong, we are overthinking these things, and we are looking for problems and solutions where maybe this is an engineering a panel. But is that something you guys also look into, like before you start these?
I can give you two answers, both very quick. From an engineering perspective, I'm an electrical engineer myself, and I've been in software projects and electrical installations, and what I can say is that technically every problem is solvable. But from the policy perspective, and this is the second answer, we are not looking at bespoke, customized solutions that player A talks to player B, and that's all. We're trying to create a level playing field for entire industries. And that's why you need a coordinated approach.
Maybe to contribute to this, I think the PV industry is particularly fragmented, and that's certainly contributing to the challenge that we're having here. Maybe one last question. I see also you had a question, right? Okay, so there's okay.
Thank you. Gabriel Abacărițe from Energonomics Romania. Stavros started with presenting a study case, a company owning different assets in different countries, producing electricity and selling it to the market. And we also heard from David about the rate of advancement of AI in being used in such situation. Maybe for David, but for any of you, the question is this. Can you estimate in how long will it take until a company like the one presented by Stavros will use AI for current operation and will compete in the market with other companies run by AI? Can we estimate when in time will we still be able to talk about market?
The last one is the philosophical question, but it is. I would say that it's very difficult to predict, but the speed of the rate of development is incredible. I mean, if you think that ChatGPT, as we know it, came out less than 2 years ago, and now we're talking about bespoke AI agents deployed for the PV sector, I would say that in a couple of years we will see a lot of interesting things happening. So, couple of years. Do we have enough AI engineers around to be able to deploy the solutions? That is probably the next questions to be answered.
I think I'll just get it running until we get kicked out. Is that how we do it? Are there more questions? There's one more question.
Dennis Lange from Uniper Renewables. And maybe to Giuseppe, because you have a big portfolio, is there also information flowing back properly regarding components when you see in a certain area or certain components are always failing, that you can tell your customers, okay, maybe for future installations, or even to the manufacturer, that you have that kind of intelligence, that you notice there are patterns, that you can improve future installations, or maybe even on the design, you could imagine something?
Not at the moment. This aligns with the DMV OEM agnostic view of offering insights to our customers. So we enable the insights, we give insights, but we try and steer away from pointing out towards certain OEMs or certain specific components.
Well, we do that. So that example I gave you of the inverter, that is being investigated now as to what is causing this behavior that has never been seen before, because it's happening with all the inverters from one manufacturer. So we are talking to them about it directly to try and get that fixed. So absolutely, we would pick it up in our designs going forward.
Okay, one more question.
Yep, thank you. Yeah, one more question. You mentioned coordination. So how do you think about standardization as a matter of coordination in that respect? Or let me say, making sure that certain rules are followed and so on, and certain taxonomies are being accepted, etc., so that we can also allow migration between different systems?
Well, standardization is part of our interoperability discussion. I think more or less the situation we are currently in is that we do not lack standards. We maybe have too many. And that's why we're having this interoperability discussion. And maybe just a short explanation of the notion of data spaces that I mentioned before. The approach that we're using for this data sharing framework is the data spaces. And the best way that I have to explain what is a data space is that it's not a space and it doesn't have any data. So we are talking about data hubs that they are located where their data are normally housed, so in the clouds of their equipment providers or the aggregators, or on their clouds. So data are not exchanging, but we are creating some connectors. So it's pieces of software that under certain conditions, which are identification management, access control, certain market actors get access to the necessary data using these software components and following all principles of security, traceability, documentation, that without moving data from one place to the other, they can get the right information needed to provide the innovative energy services. So this is the approach that we are using in this expert group, and well, hopefully it's the right one.
Thank you very much. Thank you very much, Susanna, Stavros, Giuseppe, David, for the interesting conversation, and have a nice break, all of you.
Thanks a lot.